And welcome back. Okay, so here in the today's video, I'm going to look is at a quick recap of GraphQL and the last topic that I saw yesterday. So GraphQL is this new way of building front-end and back-end applications. It's a new query language. That the beauty of this is that we can see all the different pieces in our server and how they relate each other. So with schema or in our GraphQL server or with GraphQL, it all starts by describing is the data using schemas, and with GraphQL queries for ask the data that you want, right? So it's much like selecting property on an object, and the thing of looking at the GraphQL, or what is the benefit of GraphQL queries, is that since the query really match closely the object from the result, we can predict what our query will return, and that includes all the property in that object, regardless how the data is stored, whether it's being whether on the backend or the database that is being used to persist the state of the application. It uses a relational database, key value, document base, wide column, or graph. So with that, then starting to look at what are the main benefits of using GraphQL rather than RESTful. Since we have this one single entry point, this is something helpful for a issue called underfetching and overfetching. By having one single entry point, so you can ask the data for that you want and get only the relevant data, right? In contrast with RESTful architectures, where, for example, when you ask or anytime you make a query or anytime you make a request to your server to query multiple collection, we lose time querying or making requests, making separate requests and in separate response for each one of those collections. And also we need to clean out or filter out the data that we want to show to the user. So that is something called underfetching, and the other is overfetching. Is since the servers now they don't need to send any additional data, like for example in RESTful architectures, where they might send you is unnecessary huge amount of data, and then you only want to show is perhaps one property or two properties from that entire massive object. So GraphQL solves that by only get the data that you want. So it solves the underfetching, overfetching. Is one of the advantages of using GraphQL. And also the it provides schemas and types, and that speed up the development. The trade-off is that since this is something new or quite new for most developers and for the industry, perhaps not in the industry, but for most developers, okay, GraphQL allow us is what am I going to say? The advantage, exactly, the advantage and the disadvantage. So yeah, I already mentioned is the advantage, and the disadvantage is yes. So since this is not a RESTful architecture, new developers that comes in or developers that are familiar with the RESTful architecture now need to dedicate time to learn it. So the learning curve is can be steep, right? And the other is since it is difficult to catch, even though that GraphQL provides some mechanisms to do that. With RESTful, we already have proven catching methods out of the box, or that we are familiar with. And the other is that this flexibility adds complexity, right? So that's part of the trade-off. And then I started to look at the GraphQL, this browser built-in testing tool for your GraphQL queries, and see that by default, when you make a query, you fetch the data. For example, something like I mean, is here. I think I am running that server, so let me look at here the local host in GraphQL here. Anyway, okay. No, I didn't run the server. Now let me run the server here. Okay, now if I navigate to this URL exactly. So by defining is the type here or the property. Okay, we can not only with our GraphQL query get one. We can not only get is one collection, okay, but also we can compose collections in our query, which is great because deep nested objects are very common on any e-commerce application or any application that has some technical depth. So I will argue that most applications have up to certain points some technical depth. So then I look also is at how or the GraphQL specification, which was founded by Facebook in 2012, and also the frameworks that allow you to use GraphQL, for example, React with Relay, and Apollo that allows you to build front-end and back-end GraphQL server. So before dive deep into that topic, first, the zero to mastery structure make us to create a GraphQL server from scratch. Cool, because with that, now I was able to create is a something called a type system. So after I install is the GraphQL package and the Express middleware from the GraphQL middleware for Express, which is here. Then I start to define is the basic building blocks of creating a GraphQL service. So here we're using is the build schema for that, and this is where we define the type system, and any GraphQL server has a type query which acts as the entry point, right? And the root value, where you define is the initial value for this type, for the type system. And when I mean the type system, okay, which going to the GraphQL specification here, that's right, on the type system. So type system this, I think this is something useful to kind of know where is this main topic, particularly type systems, what are the use case, okay, and the reason why it exists. So you can read enough to develop some intuition about what is this, what it's doing, and put that at practice. So the GraphQL type system describes the capability of a GraphQL service that is used to determine if a request operation is valid, the type of the response result, and determine or describe if the input value of a variable uh, describe the input value of a variable to determine if the value provided at request time are valid. So this is it makes some checking here, it makes some validation here, right? And this is the type system. So back to our course here, or into our example. Then start to test our API or GraphQL endpoint using the HTTP post verb and passing is a raw JSON object, so we get the value from that. Okay. Then I started to design is an e-commerce schema, and again something that I mentioned before. So that the nested objects are very common in any e-commerce application or any application that has some technical depth. So GraphQL is a great candidate for that. So it's actually amazing how easy it is to query data structure, a really complex data structure, to get the data that we need. So since our API is now organized in types and fields rather than endpoints, there is no need to make multiple queries to endpoints like in a RESTful API. So with that huge introduction, I wrote the type system for that small e-commerce with products and orders like this, with products, something like this, with products and orders here. Okay. Again, this is something that I organize in a way that allows to scale our application. Okay. Or this is something that you're gonna see in large scale application, right? So why am I looking at this? Because this is something important to know and to look, especially if you're going to start in a GraphQL server at scale or in production. That there are a couple questions that you might ask, like how you can, when scaling your GraphQL server, how you can break down your type system. Perhaps here is too small, but in our case it's something large. How we can scale, or how can we split our type system into multiple files? How can we organize our GraphQL server by functionality? And how can we make our query, or in this case something like here, so how can we organize our server when we need to add more complex logic when we fetch data? So I already asked these two questions, or I already answered these two questions by splitting your schema using GraphQL files, and in the entry point, in our case the servers, or the server.js, we rely on GraphQL tools that underneath the hood they're being used by Apollo. And with that, first we import is the next executable schema, and this is to pass is the string of schemas or types here, and we rely on another GraphQL tools like load file sync So what you're telling here is a type array is, hey, I just want you to iterate through the entire project. In our case, because we pass this regular expression, I want you to iterate through the entire project folder structure and look out for any GraphQL files. This approach is something great as long as you define its valid schema and there is no name conflict. So, uh, so that's great. Okay, so that's great. And so far, we have saw is, or I saw is the schema, which is part of the component, especially for creating a large-scale GraphQL application schemas, and resolvers. So what resolvers are, or what are resolvers? I correct. So resolvers, okay. The answer that relies on how GraphQL query works. Okay, so GraphQL always determine when a query is valid by looking at the schema and then execute that query. So when executing that query, the value of the property or the field is determined by a function called resolver. So in other words, anytime that you make a query, GraphQL verify if that is valid by looking at the schema and then execute the proper function to determine the value of that field, aka the resolver. So when a field is provided in your query, for example here, so when a field is provided to the query, the corresponding result is called to provide the value. So in our case, when we define a field, the corresponding resolver is called the corresponding result is called to provide the value, right? To provide this value. And when the server has called all the resolvers found in that query, here when the resolver or when the server has called all the resolvers found in that query, then you wrap up and send back to the front end. Interesting, right? Interesting. So why do we need this resolver function? What are the problems that it solves? So since right now we have defined the root value here as in our case this mock data that we are importing, okay, or dummy data that we're importing here. So instead of using the root value that comes from our hard-coded data, since this is not a realistic scenario, we need a function called resolvers. And what is the problems that the resolvers do? So for example, if you want to make async operation or async database operations or any API calls, you want and you can to do that on this function, on the resolvers. And the way to do that is by defining as the object, all right, and the type system here with the product and the orders. So each one of those are an arrow function, an anonymous function that they have a couple arguments. So pairing is when you pass the root value that you provide. Okay, the other is the argument that is being used when you want to filter out data. The other is context that is being used to pass data among resolvers. For example, if you want to pass some authenticated user data through your resolvers, and the other are info, which is is the current state of that operation. So most of the time, we are going to use parent. Depending on the context, you can, or you probably should, use all of those arguments. So in our case here, what we did is just to simulate, okay, an async operation using promise with the result, right? An async operation with the promise. So, all right, great, makes sense. And so by looking at this, all right, by looking at this, so it, as you can see, it's something that is quickly get unmanageable, or is something that is hard to maintain as you keep adding resolvers for all of your types, right? So that, my friend, is where we left here, okay? So that is exactly where we left yesterday, okay? So args, context, and info, that's right. So if for the data that can be shared all across different resolvers. For example, if you want to pass authentication data about which user logging into every of all of our resolvers. Info that contains some information about the state of our operation. So that's right. So now I'm going to look is how to modularize large GraphQL projects, especially using
resolvers in large GraphQL. Welcome back. How do we organize our resolvers in large GraphQL projects?
And for that, let me look at the module. Come on. Oh, come on, man. What do you think you're doing? Is this modularizing large GraphQL project. Modularizing GraphQL projects resolvers. Exactly. So modularizing large GraphQL projects resolvers. Modularizing large GraphQL projects resolvers. And here we are.
How do we take advantage of our more modular folder structure that we introduced for our schemas, just like we did with our schema?
So how do we organize our project just like we did with our schemas? But in this case, with our resolvers.
Our resolvers can also be loaded in based on some file path. thanks to this excellent load files sync function from our GraphQL tools library. Let's say that our resolvers are split up so that the orders resolvers live in the orders folder under a orders.resolvers.js file. Oops, and I need to make sure that's JS. And products has product.resolvers.js. We can now call inside of server.js this load files sync function to look for that file name pattern. So just like with our .graphql files, we're going to use the path.join function to look inside of the current directory, and we're going to join that with this file pattern that looks inside any subdirectories for a file that ends in .resolvers.js. We're going to take those resolvers and pass them into a resolvers array. This array can now be passed in to make executable schema in place of our resolvers object. We'll remove our old resolvers and just pass in resolvers array. Now, how would we write our resolvers in a more modular way? We know that we want to export from our module, so module.export an object which contains this query property with all of our resolver functions for each field or query that we want to support. So for products, we'll have our products function, again using this anonymous function syntax, and in our orders resolvers, we'll have something very similar. We'll have a module.export with a query for the list of orders. The query object in our orders resolvers will be merged in with the products query resolver when we pass it in to our make executable schema. The result will be a single query object that contains both orders and products. Now, to get the list of products for our API, we could again use this parent argument and return the value from that, so parent.products. But we've already decided that's not very realistic. In large-scale projects, we would have a products model that contains functions like, for example, a function to get all products. And this function would make whatever API calls and database queries to get all the products in our e-commerce application. Let's use this pattern in our example here. Our array here is our in-memory database. So let's assign that to a constant that we'll call products. And our getAllProducts data access function in our model is taking our in-memory database and listing all of the products. So return everything in our products list. Our model will now export all of these data access functions to be used in our resolvers. So getAllProducts is our one export from the products model, and in our orders model, we'll do much the same. We'll set our list of orders and then have a function to get all orders, which returns everything in our in-memory database, this list we just made. Let's make sure we're calling return, and then export that getAllOrders function to be used in the orders resolvers. So getAllOrders, which we can now import inside of this resolvers.js file. What we're going to do is const orders model equals require from the current folder orders.model, and now we no longer need to rely on the root values, those hard-coded values that we passed directly into GraphQL, but instead we can use our orders model and whatever functionality it supports to access our orders data. Now our resolver will return orders model.getAllOrders, and regardless of whether that's an asynchronous function or a static value, the correct data will be returned. In GraphQL, the best practice is to keep your resolver functions as small or thin as possible and use the functionality in other modules or other models to do all of the hard work. Now we could completely change the implementation of our orders model to, for example, access a SQL database and fetch all of the orders from there. And as long as we keep this getAllOrders function, using that as the interface, as the way of accessing our data, well, our resolvers don't need to change. It's only the implementation of our model that needs to be swapped out. This is what we want our large GraphQL projects to look like. All right, so let's do the same for our products resolvers. In our products model, we have this getAllProducts function, and let's make sure we're exporting it correctly with module.exports and not module.export. There we go. Now in the products resolvers, we can import this function. So we'll say const products model equals require from the current folder products.model, and we're no longer using the parent, but instead returning from the products model all products. And there we are. Now in our server.js, we no longer need this root object, so we can remove that, and we no longer need to pass in these default values into GraphQL. Instead, the data all comes through our executable schema from each of our resolver functions that talk directly to our models. This is a much more realistic, real-life GraphQL project structure. This is also how I would structure my own GraphQL project. All right, our resolvers right now are super simple. In the next video, let's explore some practical use cases for resolver functions, where we pass in arguments and use those arguments to filter the data that comes back in our queries. It's going to be a good one, so I'll see you there.
Yeah, no doubt that it will be a good one. No doubt that it will be a good one. Okay.
Resolvers have been quite basic. We just Welcome back. Right now, our queries and the corresponding resolvers have been quite basic. We just return back all the data in our list of products, or all the data in our list of orders. What if, instead, we wanted to get a single product by its ID? Or if we wanted to filter our products to get back those that are in some price range? These are super common use cases. On Amazon.com, a product details page would get the details for some individual product based on its ID. There's no need to query the entire list of products when loading that product details page on the front end. And when searching for products, our users will very likely be interested in filtering what products are shown to them based on different criteria, with price being a very important one. All right, so let's support both of these cases in our own GraphQL server. So what is the GraphQL approach? We're going to be using parameterized queries, or queries which accept arguments. Just like when we list all of our products, we're going to be adding a new query at the top level of our schema. This time, instead of listing all products, we're going to name our query to filter products by price, products by price. This is going to accept two arguments, which we include in our schema in these parentheses, and these are going to be the minimum price, which is going to be compared against a price. So it needs to be a float, which we'll add after the name of the argument. We're also going to have a maximum price for the upper limit, which is also a float. Now, just like before, this query will return a list of products, with product as the type, surrounded by these square brackets. To keep things simple and not worry about undefined values, we're going to say that both the minimum price as well as the maximum price are required values with this exclamation mark after the type. Now, to implement this query, we need to add a corresponding resolver. It's going to live in our products resolvers because it has to do with our product model. So we'll add it as a query underneath products with a property that matches the query name, so products by price. Now, unlike for the getAllProducts resolver, this resolver will make use of one of the arguments that GraphQL passes each resolver. So this is going to be an anonymous function, and remember that the possible data that we can get includes the parent, which might include any root default values if we had them, and also this args argument that contains any data passed into this query. It's this args argument that's going to be key to creating these filtered queries. To get a better picture of what this looks like, let's take a look into our graphical interface. Say instead of querying all the products for their description, we only wanted to get the description of the products that cost between $10 and $50. If we know there's a query that allows us to get products by price, we could add that as the name of our query. Any arguments to this query would go in parentheses immediately afterwards. We know that we're querying by price, and we're going to need a minimum, which is $10, and a maximum, which will be $50. Right now, we haven't completed the query, so GraphQL is telling us that there's no matching query with that name, but this is what we're trying to build. We now have a pretty good picture what we're aiming for, so let's see how we might support this in the server. We pass in the minimum and maximum price as arguments that are going to come back as args.min, that's the name of the parameter when we made our query in GraphQL, and args.max. These are going to be values that we pass in as arguments to some function in our products model. We're going to have a new function below getAllProducts that will instead be function getProductsByPrice, which filters the products between the minimum price and the maximum. The implementation of this model function will depend on what our data model is, whether it's this in-memory list, SQL, MongoDB, another API, or something else. With our list, we know we already have this products.filter function that will return the products that pass this predicate, this function here, which takes a single value from our list, so a single product. And in our case, we're filtering those products, so we return true when the product price is greater than the minimum and the product price is less than the maximum. If we wanted to include the minimum and maximum in this range, we would include this equal sign in our comparison. So now products with a price of exactly $10 or exactly $50 are included in the result. And we want to return the list of products that passes our filter. Just like that. To use this function, we need to add it to our exports and then call it in our resolvers. To get the result for products by price, we return products model dot get products by price, passing in args.min as the minimum and args.max as the maximum. Now notice that we're not using the parent argument in our resolver. The GraphQL convention, when you're not using one of the earlier arguments, is to name that argument using an underscore. If there were two arguments not being used, you would use two underscores for the second argument, and so on. There we go. As an exercise, see if you can implement a product by ID resolver and a corresponding product query in the schema. Oh, and before you go, we should name our arguments in the schema the same as what we name them when we write our queries. So remember, in GraphQL, we used min instead of min price and max for the upper limit. If we now run our server and refresh GraphQL, notice that the product by price query was executed and we're getting back a single product, the red shoe, because the blue jeans cost more than $50. To verify that every product being returned is in our price criteria, we could modify our query and include the price below the description. Let's execute that query, and we see our red shoes indeed match our filtered criteria. Great stuff. All right, back in our editor, take a quick pause, see if you can implement a query to get an individual product by ID, and I'll see you in the next video to compare notes.
Cool. It's like query products by ID, the mutations. Okay. Yeah, give me a second here. Yeah, give me a second here. Okay. So with that, we'll wrap up this video, and I see you soon. Take care. Bye bye.